So here's the first section, 11.1, vector space of vectors in the plane. I'm going to show you, that's why I need, here's the important thing. We need to know how to write the component of each vector, perform the operation, and the third thing, write the vector in linear computation. If you took the linear algebra before, you already have some notes about how to write down the vector, but we're going to go through fast on this, and I'm going to solve some examples. And the component form of a vector. How is going to be the component form of the vector? So this one, here's the vector space. It's a directed line segment is used to represent such a quantity as shown. We already took this one. It's a line between 2 points. This point is called the initial point, and this point is called the terminal point. How are you going to represent the vector? You're going to write down like this. It means this is a vector. But what's the meaning of the vector? The vector means the distance between these 2 points. So if you have 2 lines, and if you want to see these 2 lines to form a vector, have the same direction, and on the same time have the same distance or the same length. You can check that. You can check that on the second page. So how are you going to represent that? It's P equal PQ. That means the distance between P and Q. This is called vector space. How are you going to perform that when you write down U, V, and W? This is mean now it's a vector space, not a variables, because now we're working with vector space. So, or sometimes you're going to see if you're doing the online assignment, you will see U with the line these. This is mean it's a vector space. It's not a variable. So you're not going to get confused, because this one is different than just U or X, Y. They're telling you, they put the line here sometimes, this is a vector space. Now with this section, every time when you see U, V, W, that's meaning these are vector space. We're not working with variables anymore. Again, these slides already exist on Canvas. I'm just gonna go through fast on the important things, and I need you to go back and read the whole slide. So here's an example. They're telling you let V be a directed line segment. There's V, which is from the point 0, 0 to the point Q, 3, 2, and let U another direct line segment from the point 1, 2 to the point 4, 4. Show that V and U are equivalent. How are you going to show that P and V are equivalent? We have to show that they have the same direction and the same length. The same direction, again, and the same length. If you look to both these, it looks like the same direction, but we have to prove that. We have to prove that these 2 lines have the same direction. First of all, we're just going to start with the basic thing. Then I'm going to give you a definition or rule how to find these are equivalent vectors or equivalent line segment. So now we're just going to say, here's the solution. We need to count the length or the distance between this point and this point. We're just going to use the distance rule. And the same thing here, we don't want to count the distance between this point and this point. We have to get exactly the same distance. So here, for this example, I think I have the solution. Here's the 2 points. We're going to use the distance formula. The distance formula between the first point, 0, 0, and 3, 2. So the first point here, 0, 0, and 3, 2. So the distance formula is going to be 3 minus 0 squared plus 2 minus 0 squared. That means it's going to be 9 plus 4, and it's going to be the square root of 13. This is the distance between point P and Q, which is the first vector. Let's check the second one. The distance between R and S. We're going to use exactly the same rule. We have another 2 points, which is, here is the second 2 points, 1, 2, and 4, 4. So I'm going to say 1, 2, I'm just showing you, and here's 4, 4. The distance formula, if you remember that, is going to be x2 minus x1, y2 minus y1. That's mean the distance formula is at here. It's x2 minus x1 squared plus y2 minus y1 squared. So the same thing is going to be 4 minus 1 squared, 4 minus 2 squared, and it's going to be square root of 13. That's mean both these line segments have the same distance. Okay? If you have questions, you can ask before we keep moving on. Like after we've proven they have the same length or the same distance, we have to find the slope. The slope rule is going to be y2 minus y1 over x2 minus x1. We're going to use exactly the same 2 points. You see the first one between P and the Q is going to be 2 minus 0 and the 3 minus 0. So the slope is going to be 2 over 3. With the second one, between the point R and S, this vector is going to be the slope for this one. It's going to be 4 minus 2. 4 minus 1 is going to be 2 over 3. That's when we have exactly the same slope. Then you see, this is the conclusion. Because PQ and RS have the same length and direction, you can conclude that these two vectors are equivalent. So now, keep in your mind, what's the meaning of the vector? It's a distance between 2 points. That's why they can use it with the physics. They can use it, they're working with vectors, but they don't know it's a vector. They just say this is the distance between 2 points. But in fact, it's a vector. Now, the vector is the distance between 2 points. Now, if you look to find two vectors, to prove that these two vectors are equivalent, we have to prove that they have the same length, and we have to prove they have the same direction. How to do that? To prove the same length by using distance formula. To prove that the same direction by using the slope. Let's extend that to get more advanced rule. If you look, the directed line segment whose initial point in the origin, we're just going to add more things on these two, the distance rule formula and the slope. With the initial point is the origin, check. With this one, if the initial point is 0, 0 to the point Q, this is the origin point. This one is called the standard. So always when you have vector starting from the origin point and goes to any point, this is called a standard vector. Let's check that on the next page. It's exactly the same thing. So U in this case, you see now, if you look to U, it's not a variable. This is a vector, okay? Why? Because they say U, it's the distance between R and S. So instead of writing down this sign, you're just gonna say U. V is the distance between P and Q. This is V, okay? This is U, this is V. Which is the same thing. How to find is the distance between this point and this one, and V is the distance between P and Q. Now, any vector start from point 0, 0 is called standard vector or standard position, because this vector starts from the origin point. Okay? If you're going to ask about this, you just have to know any vector start from the origin point is called the standard position. A direct line segment whose initial point in the origin can be uniquely represented by the coordinates of its terminal point. That makes sense. Any vector starts from the origin point, like this one. When you represent this vector, you don't have to write down this point. You're just gonna write down the terminal point. Like you're gonna say Q to the V1 or V2. Like the previous example, the Q, let's say, or V. If you remember the point is 4, 4, we can say that V to the point 4, 4. That means this is a vector with the point, the first component is 4 and 4 because it's a standard position. That means it's started from the origin point and end to the point 4, 4. Okay, that's called the standard position vector. If you look, how many coordinates do we have here? We have X and Y. So I'm talking about the distance of the vector in which coordinate? In the coordinate X and Y. Then we're going to extend that to X, Y, Z. Then we're going to extend that in N coordinates. Okay, so that's the beauty of vectors. Like if you check in physics, they're going to find the distance between 2 points in X, Y coordinate. But when we extend that to N direction, that means we're going to find the vectors in N direction, like not just X, Y, X, Y, Z, and there's another direction. So we're going to work as an ND, not 2D, 2 direction, ND. You see there's a 3D. You heard about the 3D? That means only X, Y, Z. But when you hear 3D, it's just a name. In fact, it's more than one direction, okay? Let's keep going. So here's the main thing. They're telling you if V is a vector in a plane with initial point is the origin and whose terminal point is V, like these are just numbers, then the component form, this is important. When you hear this one, of V is, you're gonna write down like this. That's how we're gonna write down a vector space V, and we need to write down the direction for this vector, okay? Which is the terminal point. We're gonna write down these two, like this. Just write down like this, V1 and V2. But be careful, this is the component form of vector V who has the terminal point and the initial point is the origin. So you have to be careful for this one, okay? That means when you grab this vector, the origin point is 0, 0, and the terminal point is V1, V2. To write down this vector V, we're gonna write down the component form, V equal, which is gonna write down the points here, which is the terminal point, okay? V1 and V2. The coordinates V1 and V2 called the components of V. Until here, it's end of the division. They add one more thing. If both the initial point and the terminal point on the original, that means this is called zero vector. In case if they ask you, write down a vector or write down a vector whose initial point equal to the terminal point. Can you write down the zero vector? because it's going to be just like a dot. This is initial point, and this is the terminal point. Okay, so just say zero vector, because zero vector is a vector also, but the initial point is going to be zero, and also the terminal point is zero. This is the compound form for the zero vector. Now we're just going to extend, like you're going to say, because we're going to work with n direction. So if I have three vectors, and I need to prove three vectors, I need to prove they are the same direction and the same length. Like how are we going to find? You have to find the distance between V1. At V1, we have three vectors. If you need to prove that these three vectors are equivalent, you have to find the distance between V1, V2, and V2, V3, and V1, V3, and find the slope between these two and these two, okay? So it's going to be a lot of a process, but there's a theorem that says, and plus from this one, we can say that U, this is the compound form with these two components, and V are equal if and only if they have the same components. So this is easier to prove that these are equal vectors by just look to the vectors. This is the compound form, and the compound form for the other vector. If we check the first components here, exactly the same component here, the second one, exactly the second one, that means these two vectors are equivalent or are equal. Okay, so this is easier to prove that two vectors are equal by just looking to the components if you write down the vector in the component form. The component form. We're going to check that. How are we going to write down this component form? Because you're going to ask, like, if you go back to the previous example, the first vector starts with the point 0, 0, and the second point 1, 2. Let's go back. 3, 2. And the second point, this is the first point, let's say U. This is the second vector, or the second vector started from the point 1, 2 to the point 4, 4. You're going to say, how are we going to write down? We're going to check. We have to check the distance between these 2 points, the distance between these 2 points, and the slope. But this way we took it now, it's easier. We're going to find the compound form for this vector and the compound form for this vector. Okay? How are we going to find the component form? Let's go back. Let's go to the next page. Here's the formula. Here's the formula to find the compound form for any vector if you have 2 points. Okay? You're just going to say Q1 minus P1, Q2 minus P2. That means the first point, the second point, just find this one, and you will see this is the vector. Let's do this one here. P, Q. So for U is going to be 3, 0 minus 3, or 3 minus 0. PQ. Q1 is a 3 minus 0, and 2 minus 0. So it's going to be the first one is going to be 3 and 2. So U, the first vector, is going to be, this is the component form. Let's check V. V with these 2 points is going to be Q1 minus P1. That means 4 minus 1 and 4 minus 2. That means the result is going to be 3, 2. So you see, I have 2 lines, 2 vectors. So this is the U and this is the V. And I have this point is P and this point is Q. Let's say this point also be Q. To prove these 2 vectors are the same length and the same direction, we don't have to find the slope, and we don't have to find the length of each one. We're just going to convert this vector to the component form, which is this rule. We're going to convert the second vector to the component form, which is this rule. These two vectors are equal or equivalent if the same components here equal to the same components here, and this component is equal to this one. So that means U is going to be equal to V. U is going to be equal to V. You got it from this process? Moreover, from the distance formula, you can see that the length, by the way, when you hear length or magnitude, these are the same, it means length, which is the distance between the 2 points, or the length of the line. This is how you're gonna say this is the length of the vector. So every time when you see these two lines with the vector, this is mean the length. If you look here, this one, it's exactly like the component form. Q1 minus P1 squared, Q2 minus P2 squared. So these are exactly the same thing here. This is the length of the vector. If they ask you, find the length of the vector, so you have to use this formula. Okay, so we're going to use this formula a lot. So if they ask you to find the length of the vector, here's the formula. Write down the vectors in the component form. This is easier way to find or to compare between two vectors are equivalent or no. Next page. These two information, just you have to know. The length of V is the norm. If you read some books, they're going to tell you, find the norm of the vector. It's mean the length of V. So they're going to say length, it's the norm. So when you see this sign, it's mean you have to find the length. Now, if the length of the vector equal 1, then V is called unit vector. If the length equal 1, this is being called unit vector. If the length equals 0, this is another, we can use it, if and only if. That's the only option. If the length, if you have vector, and the length of this vector equals 0, that means this is the 0 vector. Okay, because we can't write down the vector with length 0. We just have one vector, which is the 0 vector. Okay, and all these exist in the notes on the slides. Now we're just gonna go to the vector operations. Not that much hard. Here is the important division. Always you have to know this one. You have two vectors. You see now, these two vectors, always we're going to write down in the component form. Be a vector space. Let's see, be a scalar. We already know the sum of two vectors. You're just going to add the components from the first vector, U1 plus V1 and U2 plus V2. The scalar multiple of C, you're going to multiply the scalar with the components of the vector. The negative of V of vector, here's the thing. You're going to say, what's the meaning of negative? Like if you have vector in this direction, the negative of this vector is going to be in this direction. So it'll be the opposite direction, okay? Because why? Because the negative sign is going to go inside these two components. So it's going to switch the vector to the other direction, okay? So that means the negative vector, or the negative of the vector. The difference between of U and V, it's in fact, here's the sum. if you have two vectors, let's say this is U and this is V. The sum of the U and V is going to be the result between U and V. This is U and this is V. This one is going to be U and V. But the difference is going to be the sum with the different direction for this vector. So this vector is going to be flipped to the other direction. For example, the same one, this is V. Negative V is going to be on this direction. This is negative V. That means to find the difference, you're going to find the sum between U and V with the different direction. So it's going to be on this part here. You're going to write down this vector here, like this, and it's going to be the sum or the difference is going to be here. That means it's going to be U minus V. Because we're going to add U with the vector V, but vector V goes to the different direction. So it's going to be just U1 minus V1 and U2 minus V2. These are all the rules for the vector operation. With this example, if you have the vector V, if you multiply vector V by half, that means, you see, you're gonna shrink the vector. Because you're gonna multiply by half, by the scalar half. So this one, the half is going to be inside the coordinate V1 and V2. So it's gonna be shrink the components. So the vector is going to be smaller. 2V, that means you're gonna stretch the vector by 2. Negative V is going to be the opposite direction. Negative 3 over 2V is going to be opposite direction, but you're gonna stretch the vector 3 over 2. That's 1.5. Okay, this is just like to show you what's gonna happen to the vector. If C is positive, then the vector is going to be on the same direction, but it's going to be stretch or shrink, but stay on the same direction as V. If C is negative, it's going to be to the opposite direction. Okay, that's the only thing you have to know. Here's the sum to show that I'm going to show you the sum is going to be how. I already explained that to you. So if you have two vectors, U and V, check here. The sum of U and V, you can choose. I'm going to fix this one. I'm going to fix the U and write down the V from here. You see this one V is going to go here. That's how we're going to find the sum. Fix one of these vectors and move the second vector to the terminal point to the first vector. So where's the U plus V is going to be the distance from here to here. So this is U plus V. Or you can fix V and move the U to the terminal point of V, and it's going to be the same thing. This is going to be U plus V. That's how it shows here. So it's up to you which one you're gonna fix. It's fine. This is just to visualize that. But when you do with numbers, you're just gonna add the components. Okay, you don't have to move U and V. You see with the second part, they fixed V and they moved U to the end point of V. That means U plus V is going to be the distance from this point to this point. This is the addition between U and V. Any questions so far? Now the same thing with the scalar. This is the addition. You see one is called resultant vector. It's happened with the forces, like when you have two forces affecting one object. So when you add these two forces, it's going to be a resultant force. But now we're working with vectors, so it's going to be a resultant vector. And here's the thing, you see, this is U and V. Again, the same thing. You're going to move V here. So here's going to be the resultant vector, which is U plus V. But if you want to check how much is going to be the result, you're just going to add the components of U and V. U1 plus V1, U2 plus V2. If you multiply by the scalar K here, this is the vector U. If you multiply, here's the components for this vector U. If you multiply by K, it's just going to be straight. If you multiply by negative, it's going to be to the other direction because it's going to be flipped. But it depends about K. K is going to be stretch the vector or shrink it. And here's how it's going to be the minus. I told you just have to, here's U and here's V. Negative V is going to be, goes to this direction because it's going to flip the components for this vector. So it'll be this direction. U minus V is going to be, there's V, this is minus V. You see the vector goes to this direction. And U minus V, the result is going to be this one or this one. Again, we're just going to use as a number, and you will see it's going to be easier. You're just going to find the addition by adding the components, find the difference between these two vectors. You're just going to find the components and you can graph it.
Do you mind if you go over this one again?
Which one?
Like the whole thing?
Oh, okay, it's fine. So here's the thing. It's exactly what I did. So I'm going to do it here. If you have the vector U here, the same thing here, and here's the vector V. Okay, we need to find the addition between these two vectors. So what you have to do, as to visualize that, the addition, we need to find, like, add this vector to this one, okay? As a numbers, you're just gonna add the components. But as a graphing, you're gonna take, it's up to you. Which vector you're gonna choose to fix? You tell me. You wanna fix U or V?
U.
Okay, we're gonna fix U. That's me, I'm gonna fix this one. I'm going to move V exactly the same thing, but to the end, to the terminal point of U. So here's V, I'm gonna move it here.
Okay.
Okay, so this is V. Where's the new vector, which is U plus V, is going to be the distance?
Yeah.
Here.
Okay.
This is U plus V. You got it?
Yeah, thank you.
The same thing, if you fixed V, you're going to move U here. So this one is going to be U. You see, U plus V is going to be exactly the same line. You got it?
Thank you.
That's what I explained. What about if you have a scalar? It depends. I told you with the scalar, like you have a vector. This is the vector U. If you multiply this vector by 2, for example, let's say it with number. Let's do it with numbers. Like the vector we have, let's say V equal 1, 2. 2 and 2. This is the vector we have, because here's the terminal point and here's the start point. If we multiply this vector by 3, 3V, This is the scalar, right? So what's going to happen to the vector? It's going to be stretched. It's going to be longer. So 3v, it's mean 3 times 2 and 2. So it's going to be 3 times 2 is going to be 6 and 6. Check what's happened to the vector, the new vector. So it's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the vector is going to be. What about if you multiply by negative number? Here is our original vector. If we multiply by negative 1,
Yeah,
what's
it's
going to
gonna
happen
flip.
to the vector? Say it again.
It's gonna flip.
It's going to flip to the other direction. So if you say negative v is going to be negative 1, 2, 2, and it's going to be negative 2 and negative 2. That's mean it's going to go to this different direction. So that's what's doing with the scalar multiple. Okay. Let's go to the next page. Here's just an example. We're going to go fast through these examples. So we're going to start working on examples on cosine, which is exactly the same process. For this vector, negative 2 and 0, and 3, 4. We have 2 vectors. Find each of the vectors. Find this vector. You see, it's multiply the vector v by half. So what is going to happen is going to be half times negative 2 and half times 5. So here is the new vector, which is going to be shrink. You're going to shrink the vector, but it's going to be the same direction. Okay? W minus v, you're just going to W. Be careful here. Like it's easy process. But like last semester, one student like lost 5 points on one sign. So be careful. It's a simple equation, but you're going to do simple mistakes. So be careful when you're working with the sign. So W1 minus V1, W2 minus V2. See, 3 minus V1 is negative 2. I'm telling you, it's easy to make mistakes here. And comma 4 minus 5. So the result is 5 negative 1. And check what happened. It's going to be different direction, different vector, because it's a minus between W and V. Okay, that's mean vector V is going to be goes to different direction. Okay. Any questions so far? Now 2W, that means we're going to multiply 2 times the W, and here is going to be the result. We're just going to add V plus 2W. Here's the vector V, and you're going to add, here's 2W. So you see, we're just going to add the components, and here's the new vector 4 and 13. And when you graph it, don't worry, it's just like graphing this is X and this is Y. Okay, so just like graphing a point, but in fact, it's a vector because the start point is 0, 0. So from 0, 0 to this point, and the whole thing is going to be a vector. Okay.
Sorry. So where did we get the -2 and the 5? Was it from the previous
-2 and 5? Because they ask you to find this one. Okay.
Yeah.
-2 and 5 from the previous.
Oh, okay.
It's a V.
Yeah.
Oh,
okay.
The same example. Yeah. It's the same example.
Cool.
But we need to find 2W. W from the previous page, which is going to multiply by 2 is going to be 6 and 8. Okay.
Thank you.
Next page, the properties of a vector operation. We already know these operations. If you have 2 vectors, exactly the same thing. 3 vectors in a plane, and let's C be a scalar and D also a scalar. the commutative property, that's mean if you add two vectors and you're just going to flip it, it's going to be the same. If distributive associative property, the zero is the identity. Any vector you add the zero is going to be the same vector. And with the inverse, by two scalars, if you multiply two vectors by scalars, you can multiply the scalars, then by the vectors. Distributive property, you have 3, 2, 1. If you distribute the vector on these two scalars, it's going to be cu plus du. Or if you distribute a scalar on two vectors. Okay, you just have to know this property. And the last one is the 1. 1 times u is going to be u, but 0 times u is going to be 0. This is the it's one of the properties. It's important with the theorem. When we prove theorem, we can use these two properties. So these are the vector operations and length and the scalar multiple. By the way, this operation is called axioms. And there's a proof for each one. Okay, so keep in your mind, these operations is axioms. I'm not going to ask you for the proof because we're not going to use the proof, but each one has a proof and they call it axioms. Okay, this theorem 11.1. This is the first theorem. Theorem 11.2, the length and the scalar. This is also important. Let V be a vector space and C be a scalar. Then you see the norm or the length. This is really important. The norm, I told you what's the meaning of the norm. It's mean the length. The length of C times V is going to be the absolute value of C and with the length of V. Okay, so when they ask you to find the length of C times V, you can take out the C. This is important when you have a proof. Take out the C and find the length of the V, but you have to find the absolute value of C. Okay, so this is C is the absolute value of C. That's mean if you have negative number, always going to be positive. There's a proof also for this one. Unit vector. This is the third theorem. This is important if you're going to take 2318 class, because they're going to ask you to normalize unit vector in the direction of V. Unit vector. What's the meaning of unit vector? You remember when I asked you if there is a vector space with the length equal 1, it's called unit vector. Okay, any vector, there's a note in the beginning, you can check that. Any vector space with the length 1 is called unit vector. So if they gave you a vector with length not 1, length 5, and they ask you to normalize, this vector, you can use this rule. What it says, if V is a non-zero vector in the plane, then the vector U, which is the new vector, V divided by the length of V, which is the same thing, 1 over the length of V times V has length 1. Okay, so if you have any vector and they ask you normalize this vector, what are you going to do? You're going to do these steps. I think that we have example. No, we don't have example. How are you gonna? You just find the length of the vector and then divide each component of V by the component by the length. The result of the new vector, when you find the length for it, is going to be 1. Okay, I think there's an example on with the sign. So this is called normalized. So if I ask you find a unit vector, keep this one in your mind. Again, find unit vector. And I give you the vector, let's say v equal 5 and 3. And like for this example, find a unit vector, and I give you the vector of this one. So we're going to do, first of all, you're going to find the length for v, and you're going to divide each component of v by the length. Each component of v by the length. The result vector, when you find the length of the new vector, the length 100% is supposed to be 1. Okay? This is important. I give you here on the side. The same thing, we already know what's the meaning of u plus v. Here is u, here is v. The distance, like imagine, here you are, and you're going to the college. When you're taking u, then you're going to take another street, v, this is called distance, as a physics we're talking now. But if you're taking u plus v, it's called what? Displacement. So tell me, which one is going to be larger? The distance or longer? The distance or the displacement? As a length, I'm talking about. As a length, the distance is going to be longer or the displacement?
Distance.
This is going to be longer. That means if you add the length of u plus the length of v, the length of u plus the length of v is going to be greater than, sometimes equal to the length of u plus v. Is that right? Distance is greater than displacement, right? Check what I'm going to do. I'm just going to clip this one. If this one is greater than this one, does that mean the distance of u plus v less than or equal the distance of u plus the distance of v? Yes or no? Check this one as well. What do you call this one? If the page, it's called what? Triangle inequality. Okay, so the triangle inequality, the distance, as it says, the distance between of the sum, the length of the sum u and v, always less than or equal the length of u plus the length of v. That's what it says here. The length of the sum u and v always less than or equal to the length of u plus the length of v. This is the triangle inequality. Always the sum, the length of the sum is less than or equal the length of the first vector plus the length of the second vector. This is the triangle inequality. Let's keep going. Standard unit vector is not that much hard. Each coordinate, the unit vector 1, 0. This is a vector, you see? 1 and the y is 0. And 0, 1 are called a standard unit vector. So when you hear standard vector, it's a vector with the initial point 0, 0. But standard unit vector is going to be the vector with the I, which is 1, 0 or j 0, 1. If you have three dimensions, it's going to be 1, or let's say yeah, I 1, 0, 0. J is going to be 1, sorry, 0, 1, 0. And K is going to be 0, 0, 1. If you have a 3 dimension, and keep going on, because we're working only with X and Y. Standard unit vector. The main thing now with the last pages is just to how to write down any vector as a linear combination from the standard unit vectors. You'll see that on the next page. You see, these vectors can use to represent any vector as a linear combination. Like if you have vector this one, you can write down the vector as a linear combination from the standard unit vectors. So it's going to be V1, you see, because times 1, V1 is going to be stay, and the V2 is going to be 0 plus 0 V2. That's me. This one is with the I, and this one with the J. So this one is called linear combination. And the scalar V1 and V2 is called horizontal and vertical components. This one now is a scalar. So it's going to be, this is a vertical, this is horizontal, and this is vertical. This is vertical because it's worked with the Y coordinate. This is horizontal because it's worked with the X coordinate. Same thing here. Let U be a vector with initial point 2, -5, the terminal point, and let V is just like a simple way. U, they ask you write each vector as a linear combination of I and J. So now you see U, we have 2 points. U, here's the initial point, and here's the terminal point. So the first thing we need to find U as a vector. So U is going to be Q1 minus P1, Q2 minus P2. That means it's going to be -1 minus 2, because this is the initial. That means U, the initial is 2, -5, and the terminal point is -1, 3. So this is going to be Q1, this is P, this is Q, Q1 minus P1, Q2 minus P2, and here's the vector. How to write down this vector as a linear combination? It's going to be -3i plus 8j. That's it. This is the linear combination. We wrote this vector as a linear combination from the standard unit vector. Okay? Same thing with W. It's telling you W is 2u minus 3v. 2 times the vector u. 2 times, here's the vector u, minus 3 times v. The average gave you v is a vector written in a standard unit vector. Okay? So now we're just going to write down the v exactly the same. Do the operation, the math, distribute the 2, distribute the negative sign, combine like terms, going to be -6i, -6i is going to be -12i, 16 with the 3 is going to be 19j. So W, the vector W is written as a linear combination from the standard unit vectors. Okay, so this is just like a simple operation, and I'm sure there is an example like this one. On whoop sign, what is telling you? Consider the following graph. Check this graph. Can you see the numbers? Find the component form of V. Keep in your mind, the component form of V. We have 2 points. The first point is 1, 3. And the second point is 4, 4. We need to write down this in the component form. This is, let's say, this is P, this is a Q. So the component form of the vector V is going to be Q1 minus P1. Let's write down the form. Q1 minus P1 and Q2 minus P2. So it's going to be Q1, 4 minus 1 and 4 minus 3. So the result is going to be 3 and 1. So this is the first thing, 3 and 1. I can write it down. 3, but here's the thing, be careful. Are we gonna write down vectors? Yes, see? So you're gonna click on the vectors, and here is the, okay, so it's going to be 3, 1, and it's already closed. Okay, now sketch this vector. Again, here is the length. We need to sketch the vector. What do you think? Which one is going to be the solution?
The last one.
The last one, which is a 3, 1.
That
3,
one.
1. Yeah, so you're gonna choose this one. X is a 3, Y is 1. Choose this one. That's it. Let's go to the second one. We have 2 vectors. Find the vector U and V whose initial point and terminal point are given. Here's the initial point and here's the terminal point. That means we have 2 vectors. And they're telling you, are U and V are equivalent? What do you think? They are equivalent or no? You can't tell. You have 2 options. If you want to find the distance between these 2 points and the distance between these 2 points, then you're going to find the length, and you have to find the length, which is the length. Find the slope. Find the slope is going to be a longer process. First thing, find the vector U, and then find the vector V. Let's do this. Question 2. The first point is 4. Here's for the U is 4, 4. And the second point is 5, 5. This is really important. They're telling you this is the initial and this is the terminal. That means this is Q and this is P. The same thing with the V. V, the initial point is, the initial point is 2, 6. And the terminal point is 3, 8. So first of all, we're going to find the vector U is going to be Q1 minus P1. So 5 minus 4 and 5 minus 4. That means it's going to be 1 and 1. The vector U is going to be 3 minus 2 and 8 minus 6. So it's going to be 1 and 2. So here's the 2 vectors. Now 1 and 2. So check, is these are equivalent? Let me type it out. So 6, 3, 8. Oh, I did something wrong. You should tell me. This is 6. This one is 6. So 6 minus 4 is going to be 2. Well, this one is 2. Now, By looking to these two vectors, you can tell these are equivalent, yes or no?
Yes.
Yes, because they have exactly the same components. So 1, 2, and with the second one, you're gonna click on the vectors here. So it's gonna be also 1, 2. Yes, they are equivalent. That's it. Submit answer. I think we can do that just for the one answer. And oh yeah, they can tell you. They can tell you it's right or wrong, which is good. So you can check each questions. It's right or wrong. Let's go to the next one. It's exactly the same thing. You're gonna you have initial point and terminal point. You have to find the vectors first, because you have 2 points. Then you're gonna check if it's equivalent or no. We still have time. I'm gonna give you like 2 minutes to tell me it's equivalent or no. Here's 2 vectors, here's the initial, here's the terminal. You have to sketch the given. Be careful. Sketch what? Not the vector. We're going to sketch the direct line segment. So that means just sketch these 2 points. 2, 0. That's mean x is 2 and y is 0. So it could be this one, 100% not this one, 100% not this one. So one of these graphs. What about 4, 3? This is 4, this is 3. So which one? This one or this one? 100% is going to be this graph, because we're sketching the line, not the vector, okay? Next step, they ask you to find the vector. So tell me how much is going to be the vector?
Can you scroll up a little bit?
Oh, okay, sorry. I'm just looking to these points.
I'm pretty sure it's 2, 3.
2, 3. Yes, because Q1, P1, so 2, 3. This is the new vector. Now write the vector as a linear combination of I and J. How are we gonna write down this? Linear combination of I and J.
It's going to be like 2i plus 3j.
2I plus 3J. Now sketch the vector. The vector we got 2, 3. So which one is 2, 3? The same option they give you, but it's going to be this one, because here's the original point and here's the terminal point. So you're just going to choose this one. Okay, I already going to solve all the questions. So let's see. What do you think? These hard? Let's keep going. The same thing. The same thing. Why it's wrong? 2i. Did I type it wrong?
When I submitted that answer, you gotta put like the arrow on top of the I and the J.
Oh, but that's oh yeah, okay. That's
Kind of dumb.
So also you can find it here. Oh yeah. So you can choose these I and J. Do you think I can choose these I and J? Let's try it. Plus.
To the left of the I, there's the arrow over that box that you gotta put over the letters.
I'm trying just to use this sign. Maybe they're gonna accept it. Okay, just trying to check. Oh, not this one. Because these are with the vectors. Let's submit. See if they're gonna accept it. Keep going down. Oh yeah, see it's worked. So both ways it's going to be right. If you put the sign, the arrow, or if you choose the same I and j from the vectors selection, okay? From these. Because this is with the vector, that means they're going to accept it. That's good. The same thing with this one. Exactly the same thing. Trying to find if there's different question. Here, let's do this one. Okay. Sketch each scalar multiple of V. So here is the V. Now V is what? V is a line or vector? V is a vector. Now where is the vector V? A, be careful. Vector V is 5, 3. We need to find 2V. I have to choose one of these is the vector 2V. So here's the thing. So here, what are you gonna do? The vector V equal, this is a question 6. The vector V equal 5, 3. 2V is going to be 2 times 5, 3. And is going to be 10, 6. So the vector 2V, 10, 6. That's me. Which option are we going to choose?
I think the
10,
second one.
This one?
Yeah.
This is 10 and this is 6. And again, I'm telling you, like, be careful when you do these symbols examples. Like, you see, it's easy, but sometimes you're going to do like, you're going to lose the point of symbol mistakes. Okay, so take your time. Negative 3V.
Do we have multiple tries on the test, or is it just one time?
Multiple choice, like with the multiple selection?
No, I mean like do we have like just one chance to answer the test? Because when I took calculus 2, you could submit the test like 2 times or 3 times. Like if you made mistakes the first time, you could like change them the next time.
Oh, okay. No, but I think, remember, Haley, remember how we doing the test last semester? Like, negative 3V is going to be what? It's just like negative 3 times V. So it's going to be negative 3 and 5, 3. So it's going to be negative 15 and negative 9. Negative 15 and negative 9, which one is going to be? You just can tell. Which one is different direction? Because the negative sign is going to be changed to different directions, so it's going to be this one. 7/2, this is a little bit hard, you have to be careful. First of all, you can't choose this one. How much if you divide 7 by 2? 6 divided by 2 is going to be 3. 7 divided by 2 is going to be 3.5. 3.5, okay. So now, that means 3.5, you're going to multiply by 5, and the 3.5, you're going to multiply by 3. So you think the vector is going to be stretch or shrink?
Stretch.
Stretch.
It's going to be stretch. So which one are you going to choose? This one, or this one? Which one is going to be the right one? Maybe this one? The first one?
Maybe, because they both stretch, I think.
Yeah, but you have to check it as a number. But as a conclusion, you're not going to choose this one. You're not going to choose this one. You have to choose between these two.
I have to choose. If I yeah, I'll choose the first one.
Okay, let's try. But don't do that on the test. Don't make you have to do it as a number.
Yeah, of course.
What about this one? The same thing.
This one I think this one's gonna shrink down.
Shrink. So 1, 2, by the way, the scale here, it goes by 2. 2, 4, 6, 8, 10. So be careful. It's not 1. 2, 4, 6, 8, 10. So the original vector is what? Is 5, 3, right? Our vector is 5, 3. So this is look like our vector. Because 2, 4, this is really small, smaller. So our vector is going to be 1, 2, 3. 2 is going to be like until here. So if you multiply by 2/3, it's going to be stretch or shrink. Don't look to me. Go ahead, use the paper. Okay, how is going to be shrink, stretch or shrink? So 2/3 times b, 2/3 with 5 and 3 is going to be 10/3 and it's going to be 6/3. That's mean is going to be 10/3 and 2. 10/3 is going to be 3 point what? 3.3.
Yeah.
3.3, okay? And 2. So which one? Which one are you going to choose?
The third one.
This one?
Yeah.
Yeah, because you see 2, 4.
Mm.
And this is 2. So this is going to be the right solution. So be careful from the scale because it goes by 2s. Seven, it's right, and the last one is right too. What about this one? This is not that much hard. Let's check. Find them. Oh, okay, the last one. Find 2/3u, 3v, v minus u, and 2u plus 5v, and you have two vectors. Just gonna find, multiply, and minus. This is not that much hard. What about this one? Find the magnitude of v. What does that mean? We're gonna tell me
The length.
the length. So how much is going to be the length for this one? Don't confuse yourself. Do you have j? So if you want to write down this vector, question 8, yes. It says v equal 6i. If you want to write down this is a standard unit form. What about if you want to write it down as a vector? This is I. Can you see j? No, that means j is equal to j equal to. So here's the form: 6i plus 0j. That means 6 is goes where? 6 and 0. So how much the length for this one? Oh, sorry, you can see.
The
How
length
much?
is 6.
So only
That's
6. So put down 6. What about if the opposite thing? If they give you a j, that's mean how much the I? 0 is going to be the same thing. So when I'm asking you, find the length for u equal 6i plus 2j. That means the vector is going to be 6 and 2. So don't confuse yourself. Let's go to the next one. The same thing here. You're just gonna add these, find the length. You have a vector. How are you gonna find the length here? See, there's another example here. Now, if you have vector, how are you gonna find the length? Like just a vector, 5, 12.
Use the distance formula.
Distance formula, but how are you gonna use the distance formula? It's up to you. You have more than one option. Do you have to use the 0, 0?
No.
No, because you're just gonna say 5 squared plus 12 squared. So, well, this one, because it's a vector, we don't have to represent the vector as a with the point 0, 0. So I'm just gonna say this is 9. So the vector is 5, 12. So it's going to be the length of V. It's going to be 5 squared plus 12 squared. And it's going to be 25 plus 144. And it's going to be square root of 169. And the square root of it is going to be 13. Yes or no? 13. The same thing with the next example. Let's see if there's a different one. The same thing here, don't confuse yourself if you see the decimal numbers. Take the first number square, the second number square, okay? I think this is the last one. Okay. So now we have two vectors. Find the length of U, find the length of V, find the length of the sum. How are you going to find the length for the sum for this one? Who's going to tell me? So if you need to find the length of U, you're just going to find the length for this vector. Find the length of V, you're going to find the length of this vector, the V. What about if you need to find the length of U plus V?
Add the vectors together first and
Yes.
then the length.
Add the vectors together, then find the length. This one, the same thing. You're going to divide U by its length. Then the result vector, you're going to find the length for it. Okay? You have a problem with this one? Yes or no? You have a problem how to find this one? You want to solve it?
You just use the vector U and you divide it by the answer for A.
Yeah. Then you're going to get a new vector.
Yeah.
Find the length for the new vector. Okay? The same thing here. And I think the same thing with this one. So this is not that much hard. These two examples, like in fact, you don't have to watch the videos. The same videos is going to be on Canvas. But here, check. To add vectors, just add their components. That's right. Yes, if you want to add two vectors, you're going to add the components. However, multiplying a vector by a value cannot be done by multiplying the value to each component. Is that true or false?
Seems like false.
Why? Because when you're multiplying a vector with a scalar,
It'll multiply both vectors by the same value.
but by the components, right? You're going to multiply the scalar by the components. So that's mean they say it cannot be done by multiplying the value to each component. So this one is going to be wrong. Maybe false statement. You see, it's just like from the slides, by understanding everything is going to be wrong statement. The last one, to transform a vector into unit vector. Be careful. A vector to a unit vector. Divide each component by the magnitude of the vector. Is that right or no?
I would say so. Yeah.
Because we're going to divide the vector. Remember how to find the unit vector? Like to find u, we're going to divide the vector v. Let's see.
Oh, that's what they meant.
The vector v by the length, right? That's mean we're going to divide v1, which is the component of the vector v, by the length. Okay, so that's mean the statement is true. Assignments.